Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is white noise. And you may have heard about this before, and you may already know how to write an audio effect that is white noise, but hear me out here, because we are going to create first a white noise maker, and that is pretty simple to do, it's just one line of code. But also, I'm going to explain why it works the way it does. And that is something you might not know. And then later, I'm going to create a second audio effect still on this video, and it's pretty simple, but it's a specific thing that you may want to do with white noise. And that is when you have new speakers and you just got them out of the shop, it's a good idea to burn in the speakers so that they respond better when you're actually using them. So we are going to create an audio effect that is using white noise, but tailored for this task of burning in new speakers when you get them. Okay, so let's get into Reaper now. And the first thing I'm going to do is today we definitely want to make sure that we're muting the master output, at least until we are sure that we are not producing any loud noises, which is something that may happen when you are writing audio effects. And then let's create a new track, and in this new track, I will put a new effect, and I will call this white noise. And we want to get rid of this boilerplate as always, as usual. And if you are new to JS effects and new to Reaper and you have no idea what's going on here, then you should watch the previous videos on this series in which I am creating all these other effects and explaining everything that's going on in this view here to create audio effects. But for now, we are just going to go ahead and start writing code. So I want to write some code that is going to run on every sample. And the code is pretty simple. So I'm going to create a sample, and a sample is a number between -1 and 1. So the way you create white noise is for every sample, you pick a random number between -1 and 1. That's how you create white noise. So what we are going to do is pick a random number, and there is already a function in JSFX called rand. When you call it, it gives you back a random number. So now I am picking by hitting Command K several times, and each time I do that, I get a different number between 0 and 1. So that's almost there. What we want is a random number between -1 and 1, not between 0 and 1. So to fix this, what we can do is to pass an argument. It's an optional argument, but when you pass an argument to rand, you get a random number between 0 and the argument you gave. So in this case, I'm getting random numbers between 0 and 2. And it's rare in this example, it seems. But yes, sometimes we are getting numbers that are greater than 1. So we are getting a number between 0 and 2. But what we want is a number between -1 and 1. Well, that's simple. We can just subtract 1. And now we get a number between -1 and 1. Okay, so this is how you can create white noise. Let's save this. And as soon as I save, the effect is already producing noise. And it's only doing that on the left channel because I only assigned to sample 0, but I can assign to sample 1 as well, only in one line. And this is creating noise. It's creating audio. There is no audio coming into the effect, but there is definitely some audio going out of the effect. And it's really loud because numbers between -1 and 1 produce noise that is as loud as the computer can reproduce. Very loud. It's a good thing that we have muted the master track before. We definitely don't want to generate audio that is this loud. So we can refer to the trick we learned in the previous video in which we created a gain audio effect, a gain knob. We are going to do that again. And we are going to create a slider that is a gain. And it's common to have a gain knob in many audio effects. So it's something that we are going to see again and again. So we are going to more or less reproduce the work from before, and we have a gain that we are going to set in dB. So the user is going to see this as the gain in dB, and it's going to start with 0 because, well, maybe that's not a good idea now, right? Maybe it's a good idea to just start with minus 12, which is more reasonable, or maybe even minus 18. How about that? That is more comfortable to the ears. So minus 18, and the person can go from minus 60, that's the lowest, so minus 60 dB, the most quiet noise that this plugin can generate. And I guess it makes sense to let them go to 0, though that's very loud. But I guess it makes sense, and I'm going to give them increments of 0.1 dB. So when I save that, now we have a slider. So it starts with minus 18, I can go to minus 60 or 0 in increments of 0.1, which is hard to reproduce because when I move the slider, it's moving more than that. But if your screen is big enough, then you may be able to go 1 by 1, or 0.1 by 0.1. Anyway, so this is the dB, but we actually want to have this value in terms of amplitude that goes from minus 1 to 1. So we're going to add a new section here that is run every time we change the slider. So now we set the amplitude to be the formula that we learned in that previous episode. It's 10 to the power of the value in dB divided by 20. And if this formula doesn't make sense to you, I'll say this one last time, you should go watch the video about the gain knob. And then finally, we have a value between minus 1 and 1, but we want to set a gain to attenuate that value. So we are going to multiply by this. And this is similar to the plugin we created, except that instead of listening to the audio that comes from the sample and decreasing the audio that is coming in, instead what we're doing is we are decreasing the loudness or the intensity of the signal that we are creating, the white noise that we are creating. Okay, so now that I save, now we can see that, yes, it's respecting the gain knob because it's generating audio at minus 18 dB, and I can increase it or I can bring it down. And now let's hear this and actually hear what white noise sounds like. I'll put on my headphones and unmute the master track, and I'm going to start very low because I definitely don't want to go too loud. So let me take this window and put it to the side for now so I can see the master. Okay. So that is already very loud. And now let's just do one more thing. And that is we are creating one sample, which is one number between minus 1 and 1, and we are assigning that to the left and the right channels. But here's what I would like to do instead. I would like to generate different white noises, one per channel, and assign them to the channel. So first of all, this would not be only stereo, but multi-channel. So if you had a track with 5 channels, maybe because you have a surround system, each channel will have a different white noise. That's just something that I want to do. And I want, so it will be multi-channel and all the channels will be different noise. They will be white noise, but different ones. So we can use the same trick we used in the previous effect and loop through all the channels. So the channel counter or the channel index starts with minus 1, and then we loop number of channel times. And the first thing we do in the block of code is to increment by 1. And now we have a way to access samples on a particular channel. And the formula here is the same, but each time it runs, each time I peak, I am generating a different value. So now all the channels are independent. And when I save this and I enable the plugin again, by clicking on the checkbox, we'll hear different white noises on the left and right ears. Okay, so it's working. For now, I am going to mute the master track again. Because what I want to do next is explain why this is working. And to explain that, I want to see the white noise, but I don't want to hear it. So I'm muting the master track. I'm enabling the plugin again, so it's generating noise again. And I put it on -18 because we are not hearing it. So that's fine. But I want to see the white noise to explain what's going on. So I'm going to add 2 plugins that allow me to see sound. The first is an oscilloscope, and we wrote this oscilloscope in a previous episode. And you can watch that to learn how this works. And the second plugin I want to bring in is a spectrum analyzer. And I think it's this one that I want. Yes, it's this one that I want. And this is the one that comes with Reaper, and we will write one of these in a future episode. But for now, we don't have one, so we are using the one that comes with Reaper. So now we can look at white noise in 2 different ways. The first is we can look at the shape of the wave that we are producing, and the shape of this wave as we zoom in. And I'm going to also zoom vertically. Okay, so that is better. And then I want to see maybe 100 samples. Let's see if I can do that. Okay, so now I'm looking at 100 samples and I'm holding. So I'm just looking at 100 samples and I stopped the capturing of new samples. As you can see, the waveform is just going up and down with no discernible shape. And that's because on each sample, we are taking a completely random value that is completely unrelated to previous values and completely unrelated to the following values as well. It's just completely random. So the wave is going up and down randomly. And in terms of, and this is a spectrum analyzer, so that this one, the oscilloscope, is showing us the shape of the wave. This one is showing us the amount of energy in different parts of the spectrum, different pitches. So this part on the left is the low values, the low pitches, and these are high pitches, the high pitched noises. And as you can see here in this graph, it's erratic, it's going up and down very fast. I guess we can change that by saying, okay, collect 1 second of audio and then show me that. 1 second of audio will be less erratic because it evens out differences in time. But that's just a visual thing. The point here is that there is energy throughout the spectrum. There is energy in the low pitches, there is energy in the high pitches, there is energy everywhere. And let's compare white noise, which is what we have now here. Let's compare that to a pure sound that has only 1 pitch. So I'm going to pause the generation of white noise and I'm going to bring a tone generator, the one that comes with Reaper. And we are going to create one of these in the near future. But for now, let's have the one that comes with Reaper. And I'm going to do it like this. I'm going to leave all the effects that we are using to generate sound here on the left. And I will put the spectrum analyzer and oscilloscope here on the right. And now this way, we can see everything in one place. So when I was generating white noise, we were seeing here in the oscilloscope energy everywhere and the wave was erratic. I will turn this on again. So yeah, we see energy throughout the spectrum and the wave is completely erratic. Let's stop holding and I will now generate a tone. It's just this, this waveform that has energy in only 1 frequency. Let's hear what it sounds like. So white noise sounded like shh. Let's hear what this sounds like just for a moment so we understand what we are working with. I'll bring down the volume. Okay, so now you know what it sounds like. This is what a wave that has only one pitch. That's what it sounds like. And you can see that it looks like a sine wave. I guess that's the best view I can have of this. Or maybe if I increase the volume, then you'll see a sine wave, and I can hold, and you can see this shape, a perfect shape like this, a perfect wave that goes up and down very smoothly. And in the frequency spectrum analyzer, there is energy in one frequency. Of course, it's not like a needle with just one frequency. It has some curve around that fundamental frequency, and there is some energy going on here in the low frequencies as well, but ideally it has energy only in one frequency. In this case, it has energy only in 440 hertz. So that's what a pure pitch looks and sounds like. And you can think of white noise as a combination of all different possible waves with all different possible pitches. Let's look at what happens when you change the pitch on this sound wave. So now we have 440 hertz, and when I increase, you can see that in the spectrum analyzer we are going to the right, and this wave now it is going up and down a lot more frequently. It's going up and down a lot more. Before it was going up and down in, I guess, once in this whole view, and now it's going up and down like 15 times. And as I increase the value, it goes up and down even more frequently. And I can hold on this, and you can see that it's so frequent that we can almost not make sense of that beautiful smooth shape anymore. So that is, and you can hear the difference as well. I guess I'll show you this. So I will put again my headphones and I will unmute this just so you can hear the different pitches. Okay, that was aggressive. But yeah, that was a very high pitch, and I guess I will turn down the volume just a bit, and I will go through the spectrum just so you can hear what it sounds like. Okay, enough of that. That's annoying to hear. But the point here is the white noise has energy in all those frequencies. You can think of white noise as if you were adding up all these waves. As I move the slider here up and down, imagine that I instantiated tons of these tone generators, not only one, but like millions of them. I instantiated a lot of them, and I added them up together. So here I have a base frequency of 440, and here I will have on the second one, and I want all of them to be the same loudness. So yeah, I will make sure that they are all in -12, and then I will change the frequency. So this is 440, and this is like 500, and this is like, I don't know, 700 or 7,000, I guess. And this is 1,000, and then this is 1,500, and then this is 1,700, and so on. Imagine if I could instantiate a lot of these guys. I'll put one more, just one more, 5,000. Did I put 5,000 before? I don't think so. So yeah, I add a lot of these guys, many of them. And what I end up with is I end up with covering the whole spectrum. I end up with a waveform that has energy in all frequencies. And in terms of shape, the more of these I added, the more erratic this shape was. It was going up and down very smoothly in the beginning, and as I was adding more and more of the sine waves, you could see the wave looking all weird. And just because I am curious, I'm going to put the gain knob that we wrote the other day. Do I need to scan for new plugins? Oh, I guess I need to update because I don't have the plugin here. So Give me a second. I will update everything and I'll put a gain knob here just so I can hear. Definitely don't want to hear it this loud, but I want to hear what this sounds like, if it's close to a white noise or if it's not. So hang on, I'll be right back. Okay, I'm back. I updated my own installation with the plugin we wrote before, and now I should be able to instantiate a gain knob. Yes, there it is. And I put it right after all the tones, and I want to decrease the gain a whole lot. And I guess I could have done with this slider, right? That's another way of doing it. Anyway, I wanted to use the thing we created before. So now we can hear what is the combination of all these pure waves added up together. So so we already have this volume very low, so we can enable this. It does not sound like white noise. But if you added a lot of these, then it would sound like white noise. The idea here is simple. What we want to do is we want to have energy in all these different parts of the spectrum. And to do that, we want to have a wave that represents the addition of all these components. And the way to do this, one way to do this is that there are multiple ways to generate white noise, but one way to do this is to just pick a random value. And that works because when we are picking a random value, that sample may be close to the sample we had before, though the two values are random, but they may be close together, or they may be far apart. When we take two random values, they may be 0.5 and 0.6, or they may be 0.8 and minus 0.7. They may be close or they may be further apart. If they are close, so let's do this to see what I mean. So here is again our white noise generator, and I will stop holding so I can actually see some samples. And again, I want to see like 100 of them. And I want to make this loud, so I am going to remove this utility and I'm going to hold. So if I have like these two samples right here, they are close to one another. They are random, but they happen to be close to one another. And then these two samples are very far apart. They are also random, but they happen to be far apart. Well, think about the sine waves we were looking at before. In a sine wave that is, I'm going to turn off the white noise and turn on the sine wave and stop holding. So on this sine wave that is low in pitch, 440 hertz, it's low in pitch, the samples are close together because the wave is really long. So if you look at two samples in a row, they are close together. On the other hand, if I take something that is like 1700 hertz and I look at that, then two samples in a row are close together because the wave is shorter, so you have fewer samples to go through the wave, so the samples are close together. And the white noise generator is picking a random value, so it's going from close together to far, from close together to far apart, close together, far apart, close together, far apart but not that much, far apart but not that much, and then close together, and then far apart but even more far apart. So if you add up the effect of all these increments, you end up with just tiny slices of waves that are shorter and that are longer and that are more frequent and that are less frequent, but you end up with an addition of all these samples or all these waveforms in all these different shapes. And that's why picking random values generates white noise. Now you know. In case you didn't before, and that's a common thing for people to say, right? If you have a simple example that you want to write, you just generate white noise by picking random values, but very rarely people explain why that works. And that's why. Because you're generating these small snippets of waves in all different frequencies that are in all these different increments. And the effect that has, if you add everything up together is that you end up with energy across the spectrum. That's how white noise generation works. Excellent. So that's one plugin that you can use. It's a white noise generator, but I said I wanted to have a second plugin that we can use that is based on white noise, and that is for burning in new speakers. When they come out of the manufacturer, the physical material they're made of is less flexible. So what you want to do is play some sounds on the speakers for a while. So we are talking about like 6 to 8 hours playing sound through the speakers to loosen up that material. And the result is you end up with speakers that sound more consistent across the spectrum and that generally sound more calibrated. So if you're doing some mixing and mastering, you want to do that to your speakers before you use them. And now the question is, what sounds do you want to play to burn in the speakers? Ideally, you would play something like white noise because it has energy across the spectrum. So it has energy that is low in frequency, and in that case, the speaker cone is moving more slowly. But it also has energy that is higher in pitch, so the speaker cone is moving more rapidly, it's moving faster. And if you add everything together, you are exercising the whole material your speakers are made of. So you're burning in your speakers ideally. So it's recommended by some manufacturers, I guess all manufacturers, that you play something that sounds like white noise for 6 to 8 hours in your speakers, and you play as loud as you can. So if you have neighbors, you probably don't want to play as loud as the speakers can because that would be too loud, but you want to play that sound as loud as possible. But here's the trick. And you could use just this white noise generator, right? It's even playing different white noises on the different channels, and it's all cool and dandy. But there is a trick. If you put the speakers right in front of one another so that they are playing to one another, and you take the signal on one channel and play that signal inverted in the other channel, then the speakers are not moving like this, but they are moving like this. And that makes all the difference because they are creating destructive interference. You can think of this speaker when it goes forward, it is pushing some air, but this speaker is pulling back, so it is negating that effect. Of course, not entirely. You're still going to hear some of that because you are not in an ideal world, but it is at least absorbing some of that wave of air, so it's taking out some of that sound, which allows you to bring the volume up. And when you bring up the volume, you can burn in, not break, but burn in your speakers more effectively. That allows you to increase the volume and not disturb your neighbors. So what we want is a plugin that is tailored for this task of burning in speakers, and it will be a white noise generator. In this case, I don't want it to be multi-channel, it will be only stereo, but it will be on the left channel some white noise, on the right channel that white noise inverted. Could you do this using just Reaper or anything else, some digital audio workstation, and without this special plugin? Of course, that's what people do every day. But we will have a plugin specially for this. Before I show you the plugin, I want to show you how you would do this in something like Reaper. So what you could do is maybe you could have 2 tracks, and I want to route these tracks such that the signal coming out of this track will go to both of them. So now we have a send to this track and I have a send to the other track. And then I just invert the phase of the signal in one of these tracks. And I may want to disable this so it's not sending to the master, it's only sending to these other tracks. So now what I did is, of course, this is important. This is only outputting on the left channel, and this is only outputting on the right channel. Oh, no, that's not pan. This is pan. So this is only outputting on the left channel, and this is only outputting on the right channel. So there you go. This is creating that effect that I'm talking about. It's outputting white noise on the left, on the right channel, and they are inverted in phase. There is a dedicated button to invert the phase of signal here in Reaper. And when I say invert the phase, what I mean is if you look at these waves in the spectrum analyzer, then, or not in the spectrum analyzer, but the oscilloscope, when this is going to, let's say that this is 0.3, the signal with the phase inverted is outputting minus 0.3. So if what this one is saying the speaker cone should push some, then that would be saying the speaker cone should be pulling that amount. So it's that the reflection that I was talking about. So yeah, this is what inverting means, and this is how you could set it up if you didn't have the plugin we are about to write. But we will have this plugin. So let's create a new plugin. And I will call this one Burn in Speakers. And let's get rid of all this code. But let's bring in the code from the plugin we just wrote. It was called White Noise. And it looked like this. So I'm copying the code from here and I am pasting the code here. And again, we'll have this notion of gain. And we are only going to change this part of the code. So the sample 0 will be this, and sample 1 is equal to sample 0 times minus 1. So now if this is generating 0.3, this will be minus 0.3, and so on. So this is how you invert the phase of a signal. You multiply by minus 1. And then let's save this. And that is it. This is already generating some white noise. And it's generating in a way that the phases are inverted. And I don't think I have any good way of hearing this because it's still going to sound like white noise, and our ears cannot really tell that the phases are inverted. That wouldn't work. So I guess one thing I could try to do is I could have a routing here such that we are only hearing one channel in one track and only hearing another channel in another track, and then we could put oscilloscopes in both of them and hold simultaneously, and then we are going to see that the signals are inverted. That's too much of a hassle to just see the effect. So I guess we can stop this for now. This session is over, and this is an effect that does what I promise it does, because we are inverting the right channel. And yeah, I'm not going to go through the trouble of actually looking at this, but in a future episode we do have I do have a plan of revisiting the oscilloscope and adding support for multiple channels, because currently the oscilloscope is only looking at the first channel, and maybe we should look at all the channels. And when we do, we'll get back to this effect, the burning speakers, and then we'll see the inverted phase on the left and right channels. We'll get to that someday, but that day is not today. For now, thank you for watching this video. I hope you liked this, and if you did, then give this a like and comment saying that you're liking this. Maybe suggest some audio effects you would like to see in this series, and make sure you subscribe, because I have many more videos of these audio effects coming up, all sorts of live coding, also tricks and things that I find in Reaper that help me. I always like to share that kind of knowledge, and any other thing that I think is interesting, the music I produce and whatnot. So yeah, thanks for watching. Make sure you subscribe, and I see you on the next one. Bye.